Welcome back to Godot Recipes. In this episode, we're going to create a character controller for our 3D animated character. To begin, we're going to assume you've already imported your art assets and set up your animation tree. If you haven't done that already, there's a separate video and text tutorial going over that. So check that out first and then come back here when you're all set up and ready to control the character. So we have our inherited scene from our character, and the first thing we'll notice is since we set our root node to be a character body 3D, it's complaining about not having a collision shape. So we want to add that, and we'll add a collision shape 3D, and we're going to use a capsule. Now, because the character's origin is set to its feet, which is a really useful thing to do, we're going to need to move the capsule shape up, and you can position it, but the values I've used here, I'm making a height of 2.4, leaving the radius at 0.5, and I'm going to move its position up to 1.2 meters. And that should give us a nicely positioned capsule shape that covers the character. Okay, the other thing you might have noticed if you're familiar with Godot's 3D orientation is that forward should be the negative z-axis, and so our character is facing the wrong direction, and everything will be reversed in our code. So we need to flip this guy around. And we're going to do that. We're going to use the rig to control the player's rotation, so I don't want to set that. So I'm going to go inside the rig here, and then the skeleton 3D, I'm going to set the Y rotation to 180 degrees, so that our character is facing to the negative z-axis. And then that way in our code, we can rotate the rig node 3D to change the character's facing direction. Another thing we need to do is set up our input map. So I've added actions here for forward, back, left, right, and jump. Left and right will be strafe. We're going to rotate the camera with our mouse, but we'll get to that a little bit later. And now let's talk about the camera. So I want the camera to follow the player around, but of course we don't want the camera to clip into walls and get blocked by things being between the camera and the player. So our camera should be able to zoom in and out, but it should also detect obstacles and zoom in automatically if there's an obstacle in the way. And we can do that if we add a spring arm 3D. Spring arm 3D is a node that projects a raycast out, and whatever's at the end of the raycast is its child, and it will move it automatically closer if that raycast collides. And so we're going to set the spring length of this to 5, so that it's nice and long. And then we're going to make the margin 0.1. That's how close it will allow things to get to obstacles. And we want the camera to not be at the collision point, because then it'll be clipping into the wall a little bit. And then we're going to set its position up above the player's head. So I'm going to set the Y here to 2.5. And there you can see that yellow line there is that camera raycast. And so to attach the camera to it, we just add a camera 3D as a child. And you'll see in the scene, the camera is positioned right here, but the spring arm will automatically move it to here and then move it forward if there are any collisions in the way. All right, and that's our node setup. Our next step is to start writing some code. So let's add a script to the night. And we're going to talk about the first part of the movement, which is just the WASD forward and back movement. So here in the script, I've got a few different variables set up for speed, acceleration, and jump speed. This will control those values, and we've exported them to make them easy to set. We're going to grab gravity from the project settings, and we're going to have a variable to keep track of whether we're jumping. And then we have some onReady variables to give us some references to the nodes we want to talk to. The spring arm, which we just added, the rig, which is our player model itself, which, like I said, we're going to rotate, and then two references to things in the animation tree. Now, if you click on the animation tree, you'll see over here under parameters these grounded and jumping conditions and the blend position of the IWR. And those are the things we set up here in the animation tree. The grounded and jumping transitions were those triggers that would trigger the transitions between the jump, parts of the jump animation. And the IWR is that blend position between idle, walking, strafing, and everything that we would set. We're going to set this 2D vector here based on our player's horizontal motion. And so that reference here will let us access these. Then we also have a reference called anim state that's a reference to that whole tree. And that's how we're going to call those transitions between animations. You know, if we're in this particular animation and we want to transition to interact, that's how we'll call it. Next, I have my physics process where we're going to add gravity, we're going to get the input, and then we're going to call move and slide. Not much to talk about there. And then how do we get our input? Well, we're going to apply our input to the horizontal motion, which is X and Z. We don't want it affecting Y because gravity is taking care of that. So we're going to temporarily zero out our Y velocity so that we can just add the vector, set the vector directly to our horizontal motion. So we get the input vector, we apply it to get our direction, and we rotate it by the direction that the spring arm is facing, because we want to always move forward in the direction the camera is facing. And so we're going to get that rotation of the camera, which doesn't rotate yet, but it will. We will interpolate our velocity using our acceleration so that we'll come up to speed, and then we'll set that Y velocity back so that we haven't lost whatever accumulated gravity we've gotten. Now let's look at camera control. So I'm adding another variable here to control how sensitive the mouse control of the camera is. And then down here, in unhandled input, we're going to look for mouse motion events. And if we get a mouse motion event, we're going to rotate the spring arm around its x-axis, which is going to tilt it up and down based on the y movement of the mouse. And then we're also going to clamp that angle so it doesn't go all the way around upside down. So this will be -90 will be looking straight down at the player, and 30 degrees will be looking from the ground up. And then we're also going to rotate the around Y, which will change the facing direction of the camera based on the left to right movement of the mouse. So take a look at what that looks like. And now I can move my camera back and forth. I can tilt it up, I can tilt it down. We get down near the ground and it's clipping into the ground a little bit. We'll fix that. And now we can see that if we press forward, I'm going no matter which way the camera faces, pressing forward is going to go in the direction that that camera faces. Now we need to rotate our player to look in that direction. So what we're going to do here is we're going to say, if we're moving, we're going to rotate the model, which is that rig, and we're going to interpolate it by that rotation speed so that we don't instantly snap to that direction. And that's just going to make us turn, right, and face in the direction of the camera like this. So now, no matter which way the camera is facing, I'm going to turn and face in that direction. Now we need to apply this velocity that we are moving at to our blend space so we play the right animation. And so I'm going to take this velocity, and since velocity is in global space, but we're rotating the player model, we need to transform that using the model rotation so that we get the velocity in model space. And then we're going to set that blend position to, it's a vector 2, so we need to set its x and y. And we're going to use the x of the velocity for x and the z of the velocity for y. And since forward z is negative in 3D space, but in 2D space, our blend space positive y was the moving forward. We're going to negate that. And then we need this to be a value between -1 and 1, so we'll divide by our max speed. So if we're going maximum speed, this will be 1. If we're going backwards at the maximum speed, it would be -1, and so on. And that is going to set the animations when we start running. So look from above, we're running forward, we're strafing to the left, we're strafing to the right, we're walking backwards. Right, how about the attack animations? Well, if I go over here to my project settings, I'm going to add an attack action, which we're going to use the left mouse button for. And then in our animation tree, we had 3 separate attacks. So I'm just going to make a list, an array here of the names of them. And that way in my unhandled input, if I get an attack action, then we're just going to tell the animation state to travel to a random one of those attacks. And if we run it here, we'll look at if every time I click, I'm going to play one of those animations. So now let's talk about jumping. So first of all, if we're standing on the floor and we press jump, then we're going to jump. And we're going to set those parameters in the animation tree, jumping and grounded. And by the way, when you type animtree.set, these will auto-suggest. You can also drag them from the inspector over if you want to fill those in. So we're going to set jumping to true and set grounded to false. Because remember, grounded will be the setting that to true will be the transition to hit back on the ground. Now the thing is, we need to know also what our is on floor status was the previous frame. So we've added a variable here called last floor that we're going to set every frame to be is on floor. And that way we can detect if we're on the floor now, and we weren't last frame, then we finished jumping. So we should set jumping to false and set grounded to true, which is going to trigger that transition to the landing animation. And then there's also another condition we could have, which is if we're not on the floor and we are not jumping, then we must have just fallen. We stepped off a ledge or something like that. So we want to jump straight to that jump idle animation and set grounded to false. Right? So that's going to call animation tree. That's going to call this transition, right? Instead of bending our knees and jumping up, we walked off a ledge, so we're going to jump straight to jump idle. Okay, so over here in the test scene, I've put the player up on top of the wall so we can test that out. So if we play this, we'll see when we're standing here, if we jump, we see the jump animations play. But if I run off the wall, right, it starts to fall. And you might have noticed if I play it again, when you walk off the wall, ooh, that sudden transition to the falling animation, that's not that great. So if we go to our animation tree and we pick this transition, we can give it a small crossfade time so that it doesn't look so jarring. And that's going to look a little better when we run off the wall. By the way, if you're experiencing that glitching when you get down low, that the camera is snapping inside the player's helmet, that's actually happening because the camera is, or the raycast from the spring arm is hitting the capsule shape of the player. And what we really want is we don't want the camera to pay attention to that at all. So really what we need to do is put the knight on a separate collision layer, because the spring arm is only checking collision mask layer 1. And when we set up the full game, we'll assign these layers so different things will be on different layers, and we can really be organized about this. But for right now, you just want to make sure your player is on a different layer than the layer that the spring arm is checking. And then that's going to fix that, because now you can go all the way down with the camera and it doesn't clip into the player. And that's it. That's the start of our character controller. Now you can start laying out your dungeon with all of the dungeon assets and give yourself something interesting to walk around and explore. And in future episodes, we will talk about how to add enemies, how to add doors that we can open and close, chests, combat, all that kind of stuff. So make sure to like and subscribe so you will get notified as soon as I add the next part. I'll see you next time. You can find this and many other Godot recipes, tutorials, examples, and tips at godotrecipes.com. Don't forget to like and subscribe on YouTube to get the latest video tutorials. And if you'd like to help support these efforts, please consider clicking the Patreon link. Thanks.